All right, so for this third video, what we're going to talk through is different ideas of how we can include more than one explanatory variable in our visualizations of our linear regression models. So these are different multiple linear regression models that we can fit that we talked about in the first two tutorials. So what we have here is we're thinking about visualizing a simple linear regression. So here we have the relationship between the average beauty score and the course evaluation score. And we're fitting a simple linear regression line through these points. What I want to point out here is that we look at each of these dots and it looks a little bit like it's kind of a strange pattern, but we think about how we're measuring average beauty score and average course evaluation score. The resolution of these data points is not very large, so there could be a lot of data points stacked on top of each of these data points. We don't actually know. So what we could do, a nice trick, if you think that your data are adhering to this sort of like possibility of them being really stacked on top of each other, a nice thing to add in is adding in this jittering. So we're moving from this geom point to this geom jitter, and we can see that this jittering like moves those dots around a little bit so that we're able to see this true relationship that might be going on. So we see this relationship between the average beauty score and the course evaluation score for all of the professors in these data. So in order for us to transition from this scatter plot that we are accustomed to making for our simple linear regressions, where we are plotting our points using either geom point or geom jitter, and then plotting a smoothing line on top of that using this method equals LM gets us our linear smoother. What we need to do if we have a categorical variable is we need to specify how it's going to separate each of those groups of our categorical variable. So here we're adding in this color into our list of aesthetics. So we're saying here, in this list of aesthetics, I want you to map the color of all of these things down here to the sex that the professor identified as, or the sex variable in our data set. So notice here when I label color up here, then it automatically colors all of my points. Down here, it also automatically colors my lines. It's possible for you to add this color aesthetic down here lower where you could get a single regression line, but here what we care about is getting both the points and the regression lines colored based off of sex. So this is what we're interested in, putting this color into our aesthetics. So that's what we end up with, is we end up with this scatter plot with these different colored points based off of sex and two different regression lines based off of the sex that the professor identified as. So if we notice that we have these regression lines and it seems like it's a little bit difficult for you to differentiate between the two of them because of these standard error bars, you can add this extra option here into your Geom Smooth function where you can add on this SE equals false piece. So this is what's going to turn off those standard error bars on both sides of your regression lines. And this makes it so it's a little bit easier for you to differentiate between the two lines. If it ends up that you're in the case where it seems like your lines are overlapping and you want to see exactly how different they are, this is a helpful tool to turn off your standard errors. So if we're in this other sort of context where we're in this multiple linear regression model where we have two quantitative explanatory variables, what you saw before was this idea of this regression plane, which plots things in three-dimensional space. I'm not going to bore you with the details of learning how to plot in 3 dimensions because that's not really what some of you are interested in. So instead, if we think about incorporating tools that we've already explored, is we can still color based off of the age variable, but instead of getting these sorts of discrete colors here, we end up with this color gradient, where the lighter colored points represent professors who are older and the darker colored points represent professors who are younger. So we see that these really dark blue points seen up here in these higher evaluation scores as well as these higher average beauty, these correspond to the professors who are younger. And then we see that these like lighter blues are mostly found over here where they're in these lower average beauty scores for our older professors. So this is what it looks like when you add this quantitative variable to your color piece. So there's another possibility where you could instead facet. So you could plot the same relationship, that same simple linear regression, and then facet based off of the age. So if we make this plot, we see that it's a little bit messy. So what R has done is it's split apart each of the different ages in our data set into its own facet, which maybe isn't quite what we would have wanted. So here, this gives us an idea of like what we're roughly starting with, and maybe from here we would want to create some type of categorical variable where we smudge a range of ages into one bin, say the 29 to 39 bin, and the 40 to 49 bin, and the 50 to 59 bin, and the 60 and over, or something like that, where we have this sort of idea that we're discretizing this quantitative explanatory variable. So these are all of the tools that we're going to use. We're going to focus primarily on this variable where we're adding in this categorical explanatory variable to color our points and color our scatter plot lines. So with that, I will leave you until the next video.